by. I would like to inform all participants that today's conference is being recorded. If you have any objections, you may disconnect at this time. To ask a question during the question and answer portion, please press star 1 on your phone to ask a question. Please stand by. Your conference will begin momentarily. Welcome and thank you for standing by. All participants will be able to listen only until the question and answer portion of today's conference. At that time, to ask a question, please press star 1. Today's conference is being recorded. If you have any objections, you may disconnect at this time. You may begin.
Good afternoon, everyone. I am Steve Seislow from NASA Communications. We are here today for the post-flight readiness review media telecon ahead of the launch of Crew 7 and the return of Crew 6. Our participants today are Ken Bowersox, Associate Administrator for Human Exploration and Operations Mission Directorate at NASA, Steve Stich, Manager of the Commercial Crew Program for NASA, Joel Montalbano, Manager of the International Space Station Program for NASA, Emily Nelson, Chief Flight Director, Bill Gerstenmaier, Vice President, Build and Flight Reliability at SpaceX, Frank Devin, Program Manager, International Space Station for the European Space Agency, or ESA, Junichi Sakai, Program Manager for the International Space Station for the Japanese Aerospace Exploration Agency, or JAXA, and Amir Al-Saya El-Ghaffari, Assistant Director General, Aerospace Engineering Sector at Mohammed bin Rashid Space Center in UAE. Crew 7 getting ready to launch Friday morning, and first up is Ken Bowersox.
Hey, thanks, Steve, and thanks to everybody online for joining us this evening or morning or whatever it is where you are. I know we've got folks that link in sometimes from all around the world. The space station is as busy as ever as we approach our 23rd year of continuous human presence with our international partners. One more step in our journey is completion of the flight readiness review for the Crew 7 mission, as well as a return of the Crew 6 astronauts. It was a good review today of the Falcon 9 rocket, the Dragon spacecraft. We talked about the crew and the status of the space station. At the conclusion of the review, everybody pulled go, and we're proceeding towards a launch at 3:49 a.m. Eastern Time on Friday for Crew 7. And then the return of Crew 6 will be roughly 5 days later, 5 or more days later, depending on weather. And so I won't say a date. We'll do that when the conditions are right to bring the crew home. The FRR is a really great part of our process here at NASA. We bring a lot of folks together. We all talk about the mission. We have a chance to air any dissenting opinions that may have come up during the reviews. But it's just one step There's lots of other reviews that happen ahead of the final flight readiness review at different levels throughout the organization, each with a greater and greater degree of thoroughness and detail, working up to that final readiness review at the agency level. I want to thank all the folks here with me, all of our international partners, and all of our program and our commercial partners who helped make all those reviews possible, who gathered all the data and did all the work to prepare us for the review today and get us to a go for the launch for Crew 7. And now to share some of those details, I'll pass this over to Steve Stich.
Thanks, Ken, and thanks to all the reporters and for the interest of joining us this evening. I also like to thank the entire NASA and SpaceX team for all the hard work to get to the flight readiness review today. It's kind of like the tip of the work that you see today. I mean, all the reviews, all the engineering analysis, all the inspections of the vehicle, a tremendous amount of work. As Ken said, we all polled go today to proceed toward launch, 3:49 a.m. Eastern on this Friday, the 25th. That docking time for a launch this Friday would be 2:02 a.m. Eastern, one day later on Saturday, August the 26th. And we do have backup opportunities as well for launch on Saturday and Sunday as well, so if we need those. The vehicle is doing well. The vehicle rolled out to the pad. The launch vehicle and Dragon are in the vertical configuration, and right now the teams are preparing the vehicle, getting the Dragon ready for what's called a dry dress or a rehearsal where the crew will go out, get in the vehicle. The entire team will practice the timeline all the way from when the crew suits up, gets out into the vehicle, close the hatch, and prepare for the launch, just like we would on launch day. That T0 time, we practice it just like it would be. It will be early Tuesday morning at 3:49 Eastern would be the T0 for that practice run. And then after that, we'll put the Falcon 9 first stage through its paces. We'll do about a 6-second firing of those engines, and that'll happen around 7:49 Eastern Tuesday morning. We'll test the rocket one last time to make sure the engines perform well, and then we'll step back and review that data jointly with SpaceX. I would say the review today was very thorough. Hard to believe it's our 7th crew rotation flight. We had a few special topics that we talked about today at the review. I think we mentioned to you in the last media telecon, we've had some corrosion on some low-flow prop isolation valves. This started back on the cargo flight, CRS-28. We had a valve that stuck closed on the oxidizer side on that mission. Teams did a tremendous job once that spacecraft got back, pulling the valve out, inspecting that valve and understanding the corrosion on that valve, and then pulling valves off of many other vehicles and looking at those. We went ahead on this particular vehicle on Endurance, which is making its 3rd flight. We swapped out some of the tank ISO valve components and remediated those for flight, and we've got a good path forward and good rationale for the rest of the valves on the vehicle. The corrosion is caused by oxidizer vapors mixing with a little bit of moisture, and the materials are corrosion resistant, but if you get enough vapor from the oxidizer along with water, you can form a little bit of acid and get some corrosion. So we're in good shape for flight. We wanted to understand it very thoroughly, and so we spent the last month or so looking at data. SpaceX did testing of different valves all across the country. We actually took one valve and analyzed it at the Marshall Space Flight Center as well. The other special topic we talked about is a system that we monitor very carefully. It's our parachute system. Back on Crew 5 landing, one of the drogue parachutes was a little slower to inflate. It took almost 5 seconds to fully inflate after the first drogue parachute fully inflated. We developed a model. Both SpaceX developed their own model and NASA. We looked through that dynamics, and we cleared that issue for flight as well. We had to look at it not only for normal return, but for any abort cases as well. And so the parachute system is something that we monitor very carefully. We have imagery of the chutes at every landing. SpaceX has done a great job recovering those chutes from every single landing, and we continue to watch that system very carefully. I would say at the pad, we are in good shape. We moved the launch date to the 25th to allow SpaceX to do some work at the pad. All that work is complete. The cladding on the crew tower is complete. The pad's in good shape. and it's checked out and ready for flight. You know, the next steps are really to get into to the dry dress and the static fire, and we take it one step at a time. We'll also monitor any other flights that SpaceX has. A tremendous amount of work by the team. I'm tremendously proud of the team, and we'll fly when we're ready, and I'll turn it over to Joel.
Hey, thank you, Steve, and thank you for joining us. Space Station continues to be a very busy outpost, and in that spirit, we had a Progress undock last night, and that sets us up for a Progress launch, 85 Progress launch tomorrow, Tuesday, at 21:08 Eastern Time. And that Progress will be on a trajectory to dock Thursday evening, 23:50 Eastern Time, or just a few minutes before midnight on Friday Eastern. As was mentioned by Steve and Ken, we finished our flight readiness review today. We met for a little under 7 hours or so. All pulled go for the continuing preparation for launch. This vehicle docked to the Zenith port, or the space-facing port. Steve mentioned launch time of 03:49 Eastern Friday, and the docking just after 2 a.m. Eastern on Saturday. Hatch opening will be about 2 hours later, and this vehicle will stay docked on board ISS for about 6 months. The Crew 6 undock will be 5 dock days after this vehicle is there. That's enough time for a good handover between the two crews, and such that the Crew 7 guys are ready to rock and roll. Crew 6 undock will include a fly around, and so we're excited to get some good fly around pictures of the Russian modules that have been added since the last fly around photos were taken, the new solar array augmentation that we've done on the USOS side, and so we're looking forward to those pictures and getting those distributed out publicly. We're excited to have 3 international partners on Crew 7. This Crew 7 team will perform just under 300 experiments while they're there docked for 6 months, with 81 new investigations on board the International Space Station. Looking forward, we're looking for a Soyuz launch on September 15th and a Soyuz undock and land on September 27th. With that, a huge thank you to the Commercial Crew Program, the Space Station Program, our international partners, our SpaceX partners, and everyone involved in making these missions a success. With that, I'll hand over to Emily Nelson.
Thanks, Joel. And thanks to everyone for calling in and for telling the story of human spaceflight. We had a thorough review today, and it was the culmination of a close look at the readiness of the teams on the ground, the crew, and the readiness of our spacecraft. Jasmine spoke at the start of the meeting this morning and talked about the importance of these reviews and the crew's confidence in our process. This crew is really looking forward to launch and their mission on ISS. And meanwhile, Steve and his crew on board, Woody, Sultan, and Andre, are wrapping up a really successful mission on ISS, and they and the ground teams are preparing for their safe return. Jasmine, Andy, Satoshi, and Constantine went into quarantine on August 11th. That's about 2 weeks before launch, which is standard. They arrived here at KSC yesterday morning, and they have started their sleep shift to get ready for Thursday night's launch. After their next big milestone, which is dry dress tonight, as Steve discussed, they're going to have a few more meetings through the week. They'll get a briefing on the weather for launch each day, but beyond that, they're going to spend a few days resting and focusing on time with their families before they get ready to strap in and launch into space. And with that, I'll hand over to Bill.
Thank you, Emily. Again, the flight race review was a very thorough review today. I think it's nice to get a chance to step back and look at all the issues, problems, and things that are going right with the vehicles. We get a chance to take a look at the Falcon vehicle, maybe in a little more in-depth way for crew flights than we do for other flights. We know the importance of flying crew and the trust that the crew puts in us in delivering. You know, SpaceX's job is really to deliver crew safely to the space station and return them safely from station. We treat that extremely seriously as a company. We put every effort into crew missions. We don't treat them like other missions. They're special for us, and we make sure we're really ready to go and the hardware is really ready to go. And I think this review showed that the teams are ready and we're ready with our hardware and systems. We still have 2 big tests in front of us, the dry dress test to make sure that the vehicle meets the crew's satisfaction. They can get in and out of the vehicle. All the accommodations are good and dragging the way they expect. And then we'll do the static fire, where we'll get a chance to make sure the Falcon rocket is really ready to go fly. And that'll be a pretty rigorous test. We'll do a detailed data review, and then we'll do the launch readiness review after that. So again, I'd like to thank NASA, ESA, JAXA, Roscosmos, and the UAE, and the 45th Space Wing for all the support they give us, the partnership, and helping us to make this Crew 7 launch successful. And now I'll turn it over to Frank DeWin from ESA.
Thank you, Will, and welcome everybody. First of all, a big thank you to NASA and the SpaceX team for preparing all the data package that we had to review today. It gave a great insight for ESA, the European Space Agency, to make sure that our crew member can fly safely to orbit. A number of firsts here for ESA. Andy will be the pilot of the SpaceX vehicle. It's the first time that we have a European crew member piloting a SpaceX vehicle, so we're really proud of that. And Andy will also be the commander of the ISS crew in the later part of his stay for actually several months, 3 to 4 months as it's planned today. So we're really looking forward to that. For ESA, these are very important missions because they can show to our member states the importance of human spaceflight and the importance of the science program that we are doing. Since SpaceX came online, we have 4 USOS crew members, and this has really improved the science that we can do on board of the space station. We have much more science capabilities, much more science hours, or hours that the crew can spend on science, and this has been great for ESA, for European ESA member states, and for our science program. Another first in this mission is that we will also have the first European astronaut, project astronaut, flying on a commercial mission with Axiom, on Axiom 3, and so we will have again 2 European astronauts on board of the space station. And I think it was some time ago, at least 10 years ago, that we had that occasion, I think, except from a small handover, I think, between Samantha and Matthias at a certain point. So really excited for these missions, and looking forward for the launch of Crew 7 on Friday morning.
Okay, I'm Sakai, Junichi, JAXA Program Manager, and first of all, on behalf of JAXA, I'd like to extend my gratitude to the NASA leadership and the space preparing the great presentation today, and all the members on the ground who devoted for the Crew 7 launch and continuous ISS operations. I'm honored to have this opportunity to announce the Japanese astronauts' flight, and as reported earlier, we have decided to go for the Crew 7 launch and Crew 6 return on the condition that something, but just including the astronauts Furukawa Satoshi are ready for the launch. This will be the first flight after the our government determined to extend ISS operation beyond 2024 last November. This is going to be the Satoshi's second long-term mission to the ISS. I believe that he will carry out a variety of the missions, which includes life, material, and physical science, and technological demonstration for future Winne exploration and post-ISS utilization with his excellent colleagues from international partners. This is confident that this progress won't stop and lead to our challenges to the Moon, Mars, and beyond. His expertise cultivated both in space and on the ground will contribute to the success in a variety of missions. I'm looking forward to this coming Crew 7 launch, and will continue to work hard for the final preparations. Thank you. And hand over to MBRSC.
Thank you, Junichi. This is Amr from MBRSC. Well, I'd like to start by thanking our colleagues at NASA and SpaceX and all their team members for completing this site readiness review, and with the other agencies. Of course, this brings us closer to the launch of Crew 7, and also at the same time the return of Crew 6, which includes UAE's astronaut Sultan and Niadi. Well, maybe all of you are aware, this is the second UAE human spaceflight mission, but the first long-duration mission. We're very proud to have partnered on this long-duration mission where Sultan has taken part. Over the past 6 months where he has been in space, Sultan has been very busy, involved in more than 200 experiments on the ISS. He performed various maintenance works on the ISS. These kind of experiments have been very instrumental in what we want to do, which is reaching out to the scientific community, researchers, and the students to be part of this mission, to be part of the space community. And at the same time, he accomplished a number of firsts for the UAE, and mainly would be the first Arab to complete a spacewalk, along with NASA astronaut Steve Bowen. He has also done close to 20 educational and community outreach events, what we call a call from space. And within these events, he reached out to more than 10,000 people, either through direct phone calls or video calls or ham radio sessions. We're very proud with what Sultan did, and he's currently in his final stages to return to Earth. Big thanks to the teams in Dubai, in the Mission Control Center, and in Houston to support the mission all the way. Once again, congratulations for this milestone, and we look forward to launch of Crew 6, launch of Crew 7, and the return of Crew 6. Thank you.
Thank you, everyone. Note to reporters and media on the call, to join the Q&A queue, just push *1 on your phone. We're going to start today with Chris Davenport from the Washington Post. Please state your name, your affiliation, and whom your question is directed to.
Yeah. Hey, Steve. It's Chris Davenport from the Washington Post. Thanks for doing this. For Gers, I guess you touched on this in your opening remarks, but I just wonder, given the high cadence of launch that you guys are doing, I wonder if you can talk a little bit about how you guard against complacency and just continuing to remain vigilant, especially when it comes to the human spaceflight missions. And then for Gers or Steve, just real quick, when you talk about the valves that you were looking at with the corrosion, where on the vehicle are those valves, or are they throughout, or are they in a specific region? Thanks so much.
Yeah, so I'll start a little bit. I think, first of all, it's important to know that we have separate teams that are monitoring all these activities. So it's not just one team that's doing Starlink flights and one that's doing crew flights. In fact, we can support launches from 3 pads simultaneously with our support teams, the way we are. So we're not overstressed, we're not overworking the workforce. Same thing with the technicians. They're dedicated to various launch sites and various pads and various vehicles. I think we're humbled by every time we learn something. We learn some small things, and then we go investigate those things, and then we learn more, and then hopefully we're then preventing some bigger problem from coming in the future. So I think there's an advantage of flying a lot, and the fact that we get to see these vehicles operate a lot, we get to see the hardware tested in various environments. When we fly Starlink missions, we'll typically fly a higher thrust profile, actually run pumps at higher turbine speeds, and then that actually lets us see how the engines really perform. Then we go fly a crew mission. We fly that crew mission at reduced levels with more margin available for the hardware. So I think that gives us another benefit of getting a chance to see this hardware operate in a more stressful environment. And then when we need the high reliability, we back off to more typical kind of values for crew missions. So I think there's a good balance between the two. I think it's easy to think that this is easy. This business is not easy. From the outside, it may look like we're flying a lot of flights and they're all trouble-free. They are not all trouble-free. They are not easy. Every time we fly, we learn something. We spend the time to go analyze it. We're very agile in the fact that we can get into tests. We have a lot of vertical integration. We can do things in Hawthorne, tear valves apart, dissect things. We use the NASA team where appropriate. We shift some of the work to them to go take a look at, and I think that strength between us both make sure we're ready to fly. So, my words are stay hungry. I say the company's words are stay paranoid. I like hungry better than paranoid, but the idea is that you just got to keep looking, and when you find some small problem, you got to really understand what it's trying to tell you, because later, when the big problem happens, you'll see the breadcrumbs that lead all the way back to that little problem at the beginning. The secret is to find those little problems, expand on those, and then help yourself to fly safer in the future. And Steve can talk a little bit about the valve, and I can add some if he wants.
Yeah, the valves are really in what we call the surface section part of the Dragon vehicle. So they're spread all across there. There's a number of panels throughout that vehicle that carry the structural load, and the valves are in that area. So outside the crew module, inside the service section, some are under the tank, some are easily accessible. The ones that we were able to, on the oxidizer side, that we were able to go take apart the dry side, the valves use an armature to go ahead and actuate, so it's an electrically actuated valve. We were able to take the valve apart and replace some of those components on what I would call the dry side of the valve that doesn't have propellant, and reassemble those and retest those on the spacecraft, and we know all those valves are functioning just fine. So hopefully I answered your question.
And I would say this is a good example of what I tried to describe before. On CRS-28, we had a valve that didn't close properly. As soon as that vehicle landed, we were immediately able to get that valve out, pull it apart, take it apart, analyze it. We shipped a piece of that valve actually to Marshall to go take a look at. They could identify the problem. And then we figured out there's a way that if we actually power the valve a little bit longer, we can actually drive through this corrosion and get back functionality of the valve. So again, we not only solved the problem, identified the magnitude of the problem, how far it was across the fleet, but then we also found a remediation to prevent a future occurrence if something like this shows up in flight.
Thank you. And again, media can push *1 to join the Q&A or *2 to drop out of the Q&A. Next up is Stephen Clark from Ars Technica.
Hi, Steve. I think my question will be just to follow up on Chris's to Gerst. Can you point to, we heard the ISO valve thing on Dragon, the parachute, drogue parachute thing that you looked at on Dragon. Can you point to a couple of things that you've learned on some recent Starlink flights with this high cadence or any other Falcon 9 launch on the launch vehicle side that has caused you to go back and kind of reassess something or inspect something on a launch vehicle for a crew mission? Thanks.
Yeah, on one of our flights, we had a pogo valve, which is a valve in the prevents the propellant from moving up and down in the system, and that valve stayed open, and we had an oxidizer leak on one of our Falcon Heavy flights. We were able to go in and inspect and see some corrosion in that valve. So again, we were able to then go inspect this vehicle, and we did an inspection to make sure that it was fine and okay to go fly. So I think that's an example of another valve, not one of these nitrogen tetroxide valves, but another valve in the oxygen system that had some salt water in it that ended up with corrosion. We were able to go find and remediate. We also had some cases where we saw some leakage in an acceptance test program of one of our valves on Falcon 9. We then went and investigated that particular leak and tried to understand where it came from. It came from an earlier step that was missed in a procedure, and then we said all the valves associated with that procedure were suspect, and then we're working through the process of identifying that all those valves are fine to go fly. So I think these are examples of things that we see on these other flights that carry forward and we can learn from and help prevent future problems.
And I would add from a NASA perspective, I mean, the SpaceX flights for Starlink and others really help us out. SpaceX sometimes can fly a change that will cut in on a crew flight much later, but they'll fly an earlier Starlink flight. We can watch that new component or the change in the component, how it flies in the flight environment, and come back and look at the data and then get comfortable with it for a crewed flight. Same thing with the cargo Dragons. You know, we fly sometimes small changes on the parachute system. For example, we're flying on Crew 7 on the energy modulator, which is kind of a shock absorber strap that goes between as we pull out the main bags from the drogue parachutes during that deployment sequence. We're flying some ties on that to keep the straps intact and not contact other parts of the system during deployment. So we flew those on a cargo flight first, watched that over actually several cargo flights. Now we're flying it on the crew flight for the first time on Crew 7. So.
Thank you. And next is Marcia Dunn from Associated Press.
Yes, hello. For Steve, I suppose, I'm not sure, perhaps someone else would like to add. Was it just chance that 4 partners are represented on this mission on the crew? Do you see it as a one-off fluke? Will there be more instances of this? And what do you see as the value of having NASA occupying just 1 seat and sharing the other 3? Thank you.
So this is Joel Marshall. I'll take a cut at that. So, we share the cost of operating the International Space Station across the partnership. So as people fly, as we have people in space, each partner gains crew time on orbit, and that's based on their contribution. And so the way the timing worked out for this one, with our integrated crew agreement that we have with Roscosmos, it was time for these other folks to fly. And so will that happen in the future? It may happen. It all depends on, the days in orbit. So we're excited to have this. The international partners are a big part of the International Space Station. I'll tell you, and maybe some of my international partners want to comment, that makes us as strong as we are today, the partnership. And so anytime we can have these opportunities, I think it's a good thing.
And from a CCP perspective, we're excited to fly our first complement of having an astronaut from each of the partners on our vehicle. And in particular, Andy flying as the pilot is a very big deal for us. He's certainly qualified with his background, and he's gone through all the right training at SpaceX and NASA and ready to go fly the flight, and that's pretty exciting for us.
Thank you. And David Curley for the Discovery Channel. You're next.
Thanks very much. Joel, ASAP in the last 2 quarterly meetings has talked about the leaks in the Russian module. Can you give us a sense of, they talked about repairs and filling them. Is this age? Is it stress on the system? And generally, what is your level of concern? Thank you.
All right, good question, David. So let me just kind of level set everybody. So we've identified 2 cracks and then an area of interest in that part of the service module there. And cracks, we're talking, people think of cracks. Each crack that we talk about is on the order of about 1 inch, actually a little less than 1 inch. And the width of that crack, about the size of a couple salt crystals. And so pretty small areas. You'd have to have a much larger crack before you were worried about it. So what have we done? We've stop drilled the cracks. We've patched it. We flew some hardware on the last Northrop Grumman Cygnus mission to go ahead and do an inspection of that patch without removing the patch, so we can do an ultrasonic inspection such that we can confirm that the crack is not growing. In addition, we've gotten some hardware samples of the metal from Roscosmos that was used, samples that was used of that module, and we're doing some additional testing. So while I'll tell you today the leak is less than a pound a day of air, we are watching it. It's something that we want to understand the root cause. We have a couple theories. The team's not ready to go ahead and say, yep, we've identified the root cause, but they do have some theories. I'm not concerned from a long-term standpoint. Today, it's more of a logistics challenge to make sure that we're replenishing that air. So from that standpoint, we'll continue to watch it. We'll continue to learn. We'll continue to do testing. And so in another probably towards the end of the year, I can give you an update on where we end up.
Thank you. And Jeff Faust from Space News, you're next.
Hi, Jeff Faust of Space News. Question for Steve Stich to return to the valve issue. Is there any commonality between the corrosion you saw in the Dragon valves and the earlier corrosion issue with Starliner valves? And is there anything from the Starliner investigation that helped with the Dragon valve investigation? Thanks.
Yeah, thanks for the question, Jeff. I would say the mechanism for the corrosion is somewhat similar, where we have on the valves an environmental seal that leaks a little bit of vapor across and into the dry side of the valve, which is the electrical part that actuates the valve, and then forms corrosion on the components inside combined with a little bit of moisture. So I would say we learned quite a bit from the investigation we did on Starliner, and it probably helped us a little get to the root cause a little bit faster on the Dragon valve issue. The materials inside the valves are a little different, and so the kind of corrosion is a little different between the Dragon valve and the Starliner valves. But it's a similar mechanism. You know, SpaceX, as Bill talked about, got the valve out very quickly, and was able to work through that, understand the mechanism for the corrosion, and then the team did a great job. One of the things we learned is it's important to have a purge up on the system. So in other words, in the service section, I have some very dry air, dry nitrogen flowing through that whole system to take vapors away from any area to where that corrosion will start. And that mitigation is a very similar mitigation to what the Boeing team is using on the Starliner service module. So there's a parallel to that as well. I think we're learning a little bit about capsules and valves between the two different vehicles, Starliner and Dragon. And, you know, we have a little bit more work to do long term, I think, on the Dragon vehicles, how to remediate the corrosion for the long term, because we really want to refly each one of these flights, you know, vehicles up to 5 times. So thanks for the question.
Thank you. And next is Will Robinson-Smith from Spaceflight Now.
Hi, thanks for taking my question. That actually provides a very nice segue to what I was going to ask there to both Steve as well as to Bill Gerstenmaier. With the Crew Dragon Endeavour now being on its 4th flight coming back down, what did you learn, sort of taking a step back, big picture, about the longevity of the Dragon spacecraft? And, you know, what are kind of the last steps needed towards getting to that 5th flight? And then I guess question more specifically to Bill, can you update us on the progress of the upcoming Crew Dragon that's in the work now, expected to debut still in 2024, or what's the timeline now on that? Thanks.
Yeah, I'll take the first part of the question. Yeah, I think we are learning one thing. The valves on the Crew 6 vehicle in orbit are cycling just fine, and so it is on its 4th flight, and when it returns, it would fly on its 5th flight. And so the tank ISO valves, which haven't had the corrosion removed from them, are working just fine. There's a manifold valve, which is a valve in between a set of pipe and the thrusters itself. Those are working just fine. So we know all those valves are working fine. What our plan really is to do is, when that vehicle gets back, is to go remove some of the valves, take a look at those, understand the corrosion. We know that vehicle has been in space longer. Actually, the corrosion sort of is remediated when you get into space. The vapor doesn't leak. There's no moisture to form. And so we'll take a quick look at that vehicle when we get back. We will likely remove some of the valves, and we'll have to step back and figure out what we do with the remainder of the valves in that vehicle. I'll let Bill answer the next part of the question.
Yeah, I think another important thing is we also have, at McGregor, we do long-duration testing of valves and systems. So we have wetted systems and valves at McGregor, so we can actually look at the components and see how they perform over time. I think that helps with the certification kind of discussion. I think the thing we're learning is space, and then also getting splashed in the ocean is a little bit different than the environment in McGregor. So we're going to now improve our McGregor tests a little bit to get a little more high fidelity to tease out some of these problems to eventually get us to the certified life. But we're, as you said, we're working on a new crew vehicle. It'll come sometime in 2024.
Thank you. And next is Gina Sunseri, ABC Network News.
Asked and answered. Thank you.
Thank you, Gina. Next, from Kyoto News.
Hi, I'm Yu Inokuchi for Kyoto News. I have just two quick questions on Crew 7 launch. Firstly, would you give us the estimated launch time on backup dates, that is Saturday and Sunday? And secondly, is there any concern about the weather at the moment for the launch on Friday? Thank you.
Yeah, I've got the backup launch times for Saturday and Sunday. Saturday, August the 26th, the launch time would be 3:27 a.m. Eastern Time. And then for Sunday, August the 27th, would be 3:04 a.m. Eastern Time. I would say on the weather, we've just started to take a look at the weather. One thing that's favorable for us relative to Florida weather is the launch time being 3:49 a.m. in the morning. Typically don't get convective activity that we get here in Florida in the afternoon, so that time is favorable. And then we get a little closer and we'll start looking at the abort weather up the East Coast and see if there's anything that would affect the abort weather. So I don't have a probability of violation or go weather for launch, but we'll start looking at that tomorrow.
Thank you.
Thank you. And our last question comes from Ken Kramer, Space Up Close.
Hi, thank you for doing this, and good luck on Friday. My question is for Frank DeVinna. Could you please give us an update on the European robotic arm? I know some spacewalks were done. Can you tell us, is that work? Is it operational yet? What will it be doing? And could you also tell us a little bit more about the Axiom 3 mission? Who will be flying, when, why, and why are you doing that? Thank you.
Yes, on the European robotic arm, the European robotic arm has been fully qualified and commissioned together with our colleagues from Roscosmos and Energia in the May-June time frame this year. There was actually a first operational mission that took place, I think, on the 7th or the 8th of August this year as well, where it was used by the Russian crew member as well. Fully by the Russian crew members. So the arm is fully operational, fully qualified. For what it will be used is really dependent on our colleagues from Roscosmos. As part of the agreement, the arm has been transferred to Roscosmos. It's now their property, and so it's for them to fully use it for the operations of their segment. It was built, of course, to help them with installation, for example, of science payloads at the outside of the Russian segment with the Russian airlock that actually the European robotic arm has relocated on the MLM, and so science experiments can be taken out of the airlock and positioned on the Russian segment. But this is just one example. It can be used for many things. On the Axiom 3 mission, why are we doing this? Of course, ESA has a lot of member states. We have in total now 22 member states that are part of our Telanovae program. All our member states have, of course, the inspiration or the aspiration to have countrymen fly to space, to have their astronauts as well fly to space, to have an inspirational program for their citizens, to have an educational program, but to advance science and technology in their respective countries. And unfortunately, ESA does not have yet its own human transportation system. We are working on that. There will be a space summit in November this year, where we will ask the top politicians from ESA member states and heads of state to see if ESA indeed should develop its own transportation system, human transportation system, first cargo and then human to LEO and later on to the moon, so that we can even become a better partner for our agencies. I think we have seen this in the International Space Station as well, the fact that we have very strong partners that have complementary capabilities is a strength, and we have the International Space Station that has shown this very clearly. And going forward in Moon to Mars and Artemis, together with our NASA colleagues, we want to be an even stronger partner for NASA in there. So that counts in that endeavor. But until we have our own transportation capability, of course, our member states also want to fly their countrymen or countrywomen to space. And the fact that through the private astronaut missions program that NASA has started, we now have this capability of augmenting our ESA crew members that can fly to the International Space Station to do even more science and even more technology and even more educational and inspirational activities. So we are very proud that we can do that. We will actually have an astronaut on Axiom 3, but there are more astronauts in the pipeline that will come. So this is not a one-off. There will be more of those missions coming in the future.
Thank you.
Cool, thank you. That was our last question today, so we are going to wrap it up, and the team is going to get back into their launch preparations. Again, launch of Crew 7 coming up Friday morning, 3:49 a.m. Eastern Time. You can follow all of the updates at nasa.gov, also on the Commercial Crew blog. Thank you very much.
Thank you for your participation. Participants, you may disconnect at this time.